Okay, so we want the area, base times height. We found the area in terms of one variable. So area is base, 2x, times our height, negative x plus 1. If I distribute that, it will make it a little easier to take the derivative. All right, so area is going to be negative 2x squared plus 2x. Okay, so ideally, want to find the derivative. So I can find the critical points and see where my maximum occurs. Because I want the largest area, and largest area means maximum. If I want the smallest area, I would want the minimum. But I want the largest, so I want the maximum. So I'm trying to maximize. So this is where 4.3 comes into, right? We're using critical points. We're going to take the first derivative. So it's just going to be negative 4x plus 2. Critical points occur whenever our derivative is 0 or undefined. Since this is a polynomial, this is never going to be undefined, right? It is, the domain is for all real numbers. So I just have to set it equal to 0 and solve. Set equal to 0, solve for x.
Can you go up a teeny tiny bit? Yeah, perfect. Just keep.
Yep.
Now we do a number line.
We could do a number line? Yes. So here's 1/2. So if I plug a number like 0 into my derivative,
Positive. Positive?
it would be positive. And then if I plug in a number like 1 into my derivative,
Negative.
it's negative. So clearly 1/2 is where my maximum occurs. Because I'm switching from going up to going down. You only can have minimums and maximums if you are switching directions. If you go up and then peter out and then go up, that's not a critical point. Right? Something weird's happening because you have a derivative of 0, but you actually have to be switching from coming up to coming down, from having a positive derivative to negative to have a max. This is one thing we missed on the quiz. Yes?
So, because it's asking for the largest area and it has to be a maximum, what happens if it's a minimum? Then what? There would be no answer if it went to a minimum instead of a maximum?
So the equation...
because the problem's asking what's the largest area the rectangle can have, but what if whatever the critical point is, it goes...
It won't.
It's a minimum.
Like it won't.
Oh, it'll never be...
Unless I write the problem wrong, it won't.
Okay, okay.
Because if you think about it,
Like it's impossible.
literally if you have a quadratic, the minimum and maximum occur at your vertex. So guess what? We could have just looked at this guy right here. Vertex, negative b over 2a. Oh, we get 2 over 4, which is 1/2. We get the same thing. That's the same place where I just found it. Surprise. I think you learn algebra 1. Definitely algebra 2. Hey, vertex. Guess what? That's where min and max occur for a parabola. So we found it here. So what is the largest area we can have, and what is its dimensions? Okay, so let's find the dimensions first. Dimensions are the easiest thing. Okay, dimensions. Remember, we are 2x. So 2 times 1/2 is just 1. So that's our base, and then what is our height going to be? All right, so we plug into the y equation. Negative 1/2 plus 1 is 1/2. So it's 1 by 1/2. So the area, well, the area you just multiply them together. 1 times 1/2 is just 1/2 square units. So plug this into 2x. This comes from negative x plus 1. And if you plug 1/2 into those, 1/2 of 2 is 1. Negative 1/2 plus 1 is 1/2. So you're plugging 1/2 in for x to find the dimensions. Because one's the base, the other's the height. Okay. Do we have questions on this one? I want to try number 2. It should be similar to one you've done before. I changed the number. It's a different number.
No.
No, it's not. We did 9 in the notes.
Got
It's 9 on here.
Did I mess up? Oh, you're right. I changed it in my notes. Okay. Yes. Did we do this one
Are we
already?
skipping it?
Well, I mean, it's exactly from the notes. My bad. I should have changed the number.
But in the notes, it gives you the curve.
It gives you the curve right here.
No, but like it like draws it for you.
Oh.
You can just like
You can draw it.
plug in like 0.
If you plug in 0, what's square root of 9? 3. If you plug in -3, you get 0. If you plug in 3, you get 0. It's a half circle with a radius of 3. Roughly, something like that. Yeah, my bad. It's the same problem. I thought I changed to 16. Question?
Yeah. I'm still kind of confused on when you just like look at the notes when you pull out the 9 minus x squared and negative 1 half y and in your brackets you have 2 times 9 minus x squared. When it's like
You're talking about right here?
yeah.
So this line right here. So if you look at this line, when you're like pulling something out, you're more or less like dividing each term by it, right? So what I was showing you in this red part was if I had, right, x to the 1/2 minus 2 times x to the negative 1/2, because that's exactly similar to what we have here. Literally, if I'm pulling out a negative 1/2, I'm effectively dividing each term by a negative 1/2. So when I simplify this, right, we have the same base, we subtract the exponents, so this is literally x to the 1/2 minus a negative 1/2 minus 2, let's see, x to the negative 1/2 minus a negative 1/2. Remember, I pulled out the x to the negative 1/2, right? The reason I was dividing by it is because I'm pulling it out, I'm factoring it out. Rules of exponents, just rules of exponents. What is 1/2 minus a negative 1/2?
0.
No, 1/2 minus a negative, it turns 1/2 plus a half is 1. Turns into x to the first minus 2 times x to the 0. So this one like effectively goes away. That's why right here we had this whole term, right? 2x squared times that whole term, and now I don't have that term right here. I don't have the 9 minus x squared to negative 1/2 because it goes away, because negative 1/2 minus negative 1/2 is negative 1/2 plus a half, which is 0. It goes away. And remember, x to the 0 power is 1. So this whole shenanigan parentheses to the 0 power is 1. That's why it goes away.
It's a whole.
So doing it with the x in the red is simpler to see what we're doing. Yeah. Because the reason I'm dividing each term by it is because I'm pulling it out. Okay. Okay, so we can skip this one since we did it. I have another one in the other worksheet. Okay, let's try number 3. A company wishes to manufacture a box with a volume of 16 cubic feet that is open top and twice as long as it is wide. So, okay, so we're going to do a couple things. Write a formula to express the surface area of the box as a function of width. Find the dimensions of the width. That will minimize surface area, and find the surface area of the box. Oh my gosh, so much to do. So let's define a couple things, right? What is really given to us? Volume is 16 cubic feet. So you know volume is just width times, or length times width times height. Length, width, height, because it's a box. That's how you find volume. Wait, you have a question? I have faith that you can. I have faith in you to know the basics. You got this. All right, what's the area of a triangle? 1/2 base times height. Area of a square, base times height. Area of a rectangle, base times height. Area of a trapezoid. 1/2 base 1 plus base 2 times height.
That's too much. Like if you give us a trapezoid, you're gonna.
I tutor this girl who's taking Algebra 1 right now, and her teacher, as a freshman, fully expect these little ninth graders to know those equations. I was like, okay. So shoot, if that ninth grader can do it, you guys can too.
No.
In ninth grade, maybe I could have done it. No.
Anyway, I'm telling you right now, I'm not giving you the equations for volume and area. I'll say it only one more time. I'm telling you right now, I'm not giving you the equations for volume and area. Like, that was assumed. You have
So
to
what
know.
do we need to know? We need to know like
Trapezoid, probably not gonna give you a trapezoid.
like
I feel like now you're gonna do trapezoids and trapezoids.
I could give you any single thing
Like a
that's
pyramid,
on
or
the
we
SAT.
don't
That's
have
fair game. All right. So volume is length times width times height. So we know it's twice as long as it is wide, right? So we know the length is literally 2 times width. Right? That is because it's twice as long as it is wide. So what I can do is I can rewrite the volume as 2 times width times height. Yeah, because instead of saying length, I just say, 2 times width. Cool. No, I'm calling it length and width and height. No. It's length and width and height. Okay, we know the volume of the box. It's 16. Right? 16 is equal to 2 times w squared times h. So I know we can put everything in terms of width, right? That's literally part A. Write a formula to express the surface area of the box as a function of the width. Well, width is in terms of width. Length, A, it's literally 2 times width. That's in terms of width. I need to find an equation. Height in terms of width. What's the last thing I wrote? I literally like this last thing. If I can get h by itself, it's in terms of w. So I can divide both sides by 2 times w squared. And what I get is h, the height, is equal to 8 over the width squared. I have all 3 dimensions in one variable. It's in terms of width. All right, and I'll prove it to you. What? Because I need height in terms of width. I need length in terms of width. That way, I can go through and ready. This is my width. This is my length, is 2w. And then my height is literally going to be 8 over w squared. So I have my width, my length, and my height. All 3 dimensions are in terms of w. They're all in terms of a single variable. Rad. Okay. Maybe it'd help if I all right, that's a 3D box, right? You can see it's open top. You can see inside. Do the lines make it worse? Maybe. Okay, so I have this box. I need the surface area. I need to find the surface area.
plug them all in. Oh, no, you find dimensions first.
What?
You find the dimensions.
I have the dimensions. Width, length, and height, and it's all in terms of w. That's what I just drew. I have all 3 dimensions.
Are we still on A?
No, so
Yes.
So what's for B is just what you can do.
B, not quite. I need to find the surface area first, and then B, we're going to use the equation we write for A, and we're going to minimize it. Yeah. And then C, once we have that, well, okay, cool. I'll find a number and then I can plug it in part C. So A, we're finding an equation for the surface area. So I need to find the equation of the surface area. How do you normally find surface area?
Oh.
Base times height. Times the sides.
So we take the bottom, right? And normally we take the bottom area multiplied by 2 plus 2 times this area plus 2 times this area. You're literally adding all of the areas of the sides. We have an open top box, meaning we only have 5 sides, right? Because I don't have the top one, I only have the bottom. So let's go dimension by dimension. So the surface area is going to be, let's see, I'm going to take the bottom of my box first. Maybe it would be helpful if I I don't know, just do the bottom. It's an open box. So all I'm going to do is W times 2W, so that's just 2W squared. Plus, I need to do W times, let's see, okay, so I have two of these sides, W times 8 over W squared, plus 2 times, right, I have 2 of these sides, 2W times 8 over W squared. Because these are, okay, ready? These two right here, it's this side and that side. That's the area. And I'm adding all of the areas together. Okay, ready? These two sides are going to be, let's see, okay, so it's this one and this one, right? So I did the sides of my box. Now, the last one, this guy is the bottom of my box.
But there's not a top.
There's not a top, it's an open top. That's why I only have 5 of the sides. That's why I didn't multiply the first one by 2, because I don't have the top of the box. I'm multiplying by 2 every time because there's 2 areas, right? The red ones. I have the front of the box area and then the back, right? So I have to have 2 of those same areas plus 2 of these areas. And normally we do 2 of these areas, but there's no open top, so I only have to do 1. Yes?
Why is
Amaya?
it 2W squared? Wouldn't it just be W squared?
It's W times 2W. This green one is showing you it's the bottom. It's W times 2W to find that area.
Oh, yeah.
Okay. Yes.
Also, how do we know which side's the open side? Like, we could, essentially, the number could be different depending on which one we make as the open.
The top is open.
Yeah, but how do we know
The
which
top's
one's
open.
top?
The height is literally goes up. It says the top is open. So length times width. Length and width are always your bottom. Hannah, length and width are always your bottom, and height always goes up.
Okay.
That's how, yeah. So the thing is, I could have swapped where these two were located. I could put 2W right here, and I could put the W there, but height has to be going up. It'd be the exact same thing. Okay, now that we have all those drawn, did the colors help a little bit to help you visualize? Okay. Now we just have to do rules of exponents. Just simplify this. 2W squared plus, 16W. Plus 2 times 2 is 4, 32W. Combine like terms. Oh, over W, sorry. 16 over W. 32 over W. So my surface area is going to be 2W squared plus 48 over W. Okay, part A. Dunzo! Wonderful.
No, never mind.
What's up?
When you're adding 16W and
32W, they have the same denominator.
32.
32
it's
over
32
W.
over W.
Yeah.
Okay.
So what we just found, that equation, that is part A. That is an equation, a formula to express the surface area of the box as a function of width, right? So that's where it goes, is right up there. Okay. So the next part, we're trying to minimize. Anytime we're minimizing and maximizing, what's the next thing we gotta do? Take the derivative. Take the derivative. Okay. So that was part A. I'll do part B in another color so we can see it better. Okay, I gotta take the derivative. So S prime is going to be 4W plus, remember this thing is literally 48 times W to the negative 1. So this is going to be minus 48 over W squared. So I'm showing it in the right side, right? The derivative of 48 times W to negative 1. Bring the negative 1 to the front times 48, and then you subtract it on the exponent. That's why I have to the negative 2 power. W to the negative 2 is the same thing as 1 over W to the 2. Okay. Rules of exponents. Yeah. If I'm being real, that's what's going to trip you up. It's not necessarily like this calc, this process that we're doing. It's going to be the algebra. And unfortunately, as you go through math, like the harder math you get, the worse you get at basic math. Yeah. Ask me how I know. Yeah. Yikes. My math skills dropped off when I was taking hard math. Okay, so I have the derivative, and we're trying to minimize. Whenever we're trying to find a max or min, we always set the derivative equal to 0. Okay, so set equal to 0. All right, trying to solve for what W will be. No, because when I multiply both sides by W squared, I get 48 is equal to 4 times W cubed. Divide by 4 on both sides. I get 12 is W cubed. And that tells me that W is just going to be the cube root of 12, which is about 2.289, and that's like literally the answer for part B. So when I was taking the derivative, I like wrote it with a negative exponent. That way it's easier to take the derivative. But it just makes it a little better if it's like with the fractions, you add to the side, and then you get multiple both sides of W squared, and we're solving. And the reason I can do that, I mean, I know W is not going to be 0, because then my volume will be 0, right? We said volume was 16, so we know we have to have some width at least. So to solve for it, just a cube root of 12.
Also, for these problems, where we only one solution for the variable.
Well, there's only one number that is exactly the cube root of 12.
Why do you want to
We're not putting on a burner right now. Yeah, I don't want to, so I just screwed under the max. Because that was the critical point, and it said maximize. Yeah. And like this one, if you put on number line, like this would be the minimum. We don't have to put on number line, so there's only one number that fits our constraints. Alright, so that's B, and then C is to actually find the surface area. So just plug this into the equation that we found before.
But we didn't find the dimension.
We do. Everything's in terms of width, right? 2W squared plus 48 over W. Right, remember, that was our equation for surface area. That was part A. Now that we have the width that minimizes the surface area, we can plug that in and find what the actual surface area is.
You just leave it as the
You could, and then when you plug it into your calculator, you'll find. Oops, 4, 5. Does it say round to? No, it doesn't say round to a certain one. Surface area, it's an area, that's why it's squared. Volume is always cubed. Cool. Okay, so the other one I want to do a couple problems off of. We can get at least 1 or 2 problems. And then you'll keep this, because if we have time on one of the 2 review days, we can go over more problems from this. Some of these, yeah, this is the one I was looking at, the 16. Smart. I don't know so much. Alright, party time. Oh my gosh. Okay, number 1, oops, was on the notes. Number 2 we can do. We could do like any of these, right? So you see there's like a pattern repeating. take a look at these problems. I'll give you like, I don't know, 10 seconds. I gotta open it up. And let's see which one do we want to do the most. Which one looks the hardest to you? Two? Let's do it.
Is this the review worksheet?
Yeah. These are the two I will, yeah. Cool. All right, rectangles to be inscribed. Did I get you one?
No, this is, I want to see if I have something around.
Okay. So number one, it's from your notes, so we're doing number two. A rectangle is to be inscribed under the curve y equals square root of 16 minus x. What are the dimensions of the rectangle with the largest area, and what is the largest area? So first, let's draw this on the graph. Oops, it's still frozen. No wonder. There you go. What is the largest area? So try to draw on the curve. Determine what our domain is. And see if you can figure out, okay, we're trying to find area. We know area is base times height because we have a rectangle. What's our base going to be? What's our height? All right, so I want you to try it first. Give it a shot before we go over it together. Ooh, that was a close one. I was hoping no one saw. That's great.
Did I ask if you were okay?
Physically, yeah. I've just been sleeping a lot. Okay. So, rectangles be inscribed under the curve. So, square root of 16 minus x. If I plug in 0, square root of 16 is 4, so I put a dot at 4. And then I want to know, where is my y going to be equal to 0?
Will they always be half curves, these?
Semi, yeah. They're always going to be semicircles when it's a square root of a number minus x squared. It's a semicircle. Oh my gosh, that's not... something like this. Oh, that's so close. I'll leave it. No. Okay. Something like that. Okay, there we go. Oh, that right side was perfect. Oh my gosh. Oh my gosh. Okay, let's see if I can do this. Can I flip? I don't think it'll let me. Nope, that's definitely not the right way.
Oh, you did it!
Nope, not the right way. Alright, whatever. That's close enough. Okay, cool. I have the curve drawn.
The left one looks better now.
Appreciate it. -4, +4. I'm not an artist. Whatever. Okay, and this is +4. Alright, so we're trying to draw a rectangle. I'm just going to choose color. So let's say our rectangle is something like this. There's like a billion rectangles we could draw. Inscribed means the corners touch our curve. So this point right here is exactly x units away from our origin.
What if you asked us to find it?
But,
the smallest area?
well, the smallest area would be 0 because you'd have height of 0. It would be a pointless problem. Yeah.
But then it wouldn't be a rectangle.
Right.
But what are the dimensions of the rectangle?
I would never ask you the smallest area because the smallest area is like infinitely small. It's literally 0.000000001 or whatever. Yeah. I would never ask you that. Try to maximize. So you want to minimize surface area because, you know, I don't know, cardboard costs a certain amount of money. And maximize volume, give people the most donuts for their money. All right. So if that distance from our origin to the right end of our rectangle is x, the total length across is just twice that. So the total length across is 2x. Because we're trying to find the area, and area is base times height. So I know my base is 2x. Question is, I need the height, and it has to be in terms of x. Well, the thing that dictates how high I am is where where the function is. Because remember, our corner is always touching the curve of our graph. So if I'm this high, I can find the y value by plugging into this equation. So our height is literally going to be y, right? And we know what y is. Y is square root of 16 minus x squared. Okay, I'm going to rewrite this a little easier because you know the next thing we're going to do in order to optimize, right, we have to trying to find the maximum. To find min and maxes, you take the first derivative, find the critical points. Okay, so I'm going to rewrite it so it's a little easier for us to take a derivative. So we need to take a derivative. Here's the dealio. We're confused when things are functions and not.
Why is it the negative 1/2?
Because square root. Oh, I'm sorry. It's to the positive 1/2. Thank you. Yeah. Because it's just a root. The same as the derivative. Its derivative will be negative 1/2. Okay. So here we must use product rule because we have two functions, right? 2x is a function by itself. 16 minus x squared to the 1/2 power, literally square root. This is a function by itself. If I have something like sine of x, don't write this, right? I'm writing it to like, trying to go over like problems that we missed as we go through class. This is one function. Remember, sine, cosine, tangent, literally it always has to be hugging something. It can't be by itself. You can't just have sin. That's not possible. It's always sine of something, right? You always have to have sine of something. This is a single function. You cannot use product rule. And so on that first problem on your quiz, if I have something like 0 equals sine of x, in order to get rid of sine is an operation. In order to get rid of sine, you have to do the inverse operation, right? The inverse operation is literally sine inverse, sine to the negative 1 power. You have to do sine to the negative 1 power. So this is not part of the problem. I'm writing it here and I'm going to erase in about 2 seconds. That's how you get rid of it. You can't divide by sine. Right? It doesn't make sense. It's like trying to divide by a multiplication symbol. Like, what are you know, it's something you can do. You can't just divide by an addition sign. Like, it doesn't make sense, right? It's not a number, it's a operation. Okay. I digress. But hopefully it's clear. We talked about it before, like, you have to know this. Unfortunately, I'm just like, I have to keep taking points off if you do something like that. Okay, so we have the area. We want to take the derivative, right? A prime, we have to use the product rule because we literally have two different functions. U is 2x, which means u prime is 2. V is 16 minus x squared to the 1/2. And then v prime is 1/2 times 16 negative x squared to the negative 1/2 times negative 2x. This was the chain rule. This second part came from the fact that, okay, once we dealt with this exponent, right, once we brought that exponent down, subtracted one here, we had to take the derivative of the function inside. That's chain rule. Well, the derivative of 16 minus x squared, 16, derivative of a constant, 0. This derivative is, bring the 2 down, negative 2x. Right, that's how I tack it on. It's chain rule. This is the reason also I'm making you do some of these quick review assignments. You gotta know. You gotta know chain rule, you gotta know product rule, right? You have to know the difference between them. Yeah. Because if I have you review these things, then hopefully you don't miss them on the test for chapter 4. Okay. Alright, we have 1 more minute. Thought we could finish this problem. Yes.
When we solve, can we take similar to the last one, and we'll get like a number, we'll get a polynomial over another thing? Like, and both have x in them?
Yeah.
And there's something equal to 0. Why is
The top you said equal to 0, and the bottom would be undefined.
Right, but should the top one be made like plus or minus? I got 2 root 2. Why couldn't it be like positive or negative?
You can't have a negative length. We're talking about rectangles. You can't have a negative side length.
So if you plug, oh, x is your side.
X is our length. Yeah. X is our distance from the origin. Remember, our base is like 2 times that. I can't have a negative length. Yeah. Okay, so cool. The solutions to these are online. When we meet Monday, we're gonna go over 4.6 lesson. And then the third,
Which is not next week?
correct.
No.
So next week we're doing 4.6 and reviewing. That's the 4 days of class. Or whatever. Alright, I'll see you guys. Have a good weekend.
Thank you.
Make good decisions. Bye bye.